Good morning, students. All of you answer these two questions. Yes, I think you know the formula for multiplicative inverse, how to calculate multiplicative inverse. You apply in the formula and give the value. Yes, I'm going to end the poll now. All of you give your answer. Only 11 students out of 30. So the question is, multiplicative inverse of 5 in mod 9 is what? So multiplicative inverse formula is AX is congruently equivalent to 1 mod M. Okay, 1 mod M. So that is the formula. Let me. Yes. So this is the formula, multiplicative inverse. AX is congruently equivalent to 1 mod M. So in the question, I have given A and M values. So you have to find the X value. So what is X is nothing but it is a multiplicative inverse. So simply we can say that A inverse. A into A inverse is congruently equivalent to 1 mod M. So first question, 5 mod 9. So 5 mod 9. So 5X is congruently equivalent to 1 mod M. So first step, before going to apply the formula, we need to apply that the first one, GCD of A comma M is equals to M. 1. If you see the first point, a number A can only have multiplicative inverse if it is relatively prime to the modulus. Means if the two numbers A and M are related, then only we can say that A is having the multiplicative inverse. So if we observe the first question, 5 mod, 5 multiplicative inverse of 5 in mod 9. So first we have to find the GCD of 5 and 9. So GCD of 5 and 9 is 1. Then, so 5, obviously 5 will have the multiplicative inverse. So how can we calculate the multiplicative inverse? Simply 5x is congruently equivalent to 1 mod M. So we have to substitute x values from 1 to 8 because it is Z9. It is Z9. Mod 9 means it is Z9. So we have to take the values from 1 to 9, 1 to 8 or 0 to 8. We have to take from 0 to 8. Anyway, something in 0 is 0. So we need to take from 1 to 8. So we 5x, suppose if you take 5 x value 1, so 5 is congruently equivalent to 1 mod 9. It is wrong because 5 5 itself. Suppose if you take 2, so then AX will be 10. 5 into 2, 10. 10 is congruently equivalent to 1 mod M. That is 1 mod 9. Yes, obviously 10 mod 9 is 1. So 2 is the answer. So for the first question, 2 is the answer. So we have to keep on substituting the X value till 8 because it is mod 9, Z9 set. So coming to the second question, multiplicative inverse of 4 in mod 10. So what is the first step? We have to check the GCD of two numbers, that is 4 and 10. If GCD of 4 and 10 is 1, then only 4 will have the multiplicative inverse. But GCD of 4 and 10 is not 1. It is 2. 4 and 10 are not co-prime numbers. So there itself we can say that 4 will not have the multiplicative inverse in Z10 or mod 10. So the answer is no value. I think you are not clear with the concept. Or if you go through this slide, so in this slide, so you go through the first point as well as the, you can directly substitute in the formula X is congruently equivalent to 1 mod M. So that is about what? That is about the multiplicative inverse. So in today's class, we'll discuss the Chinese remainder theorem. Okay, so Chinese remainder theorem is also part of the number theory, which will be useful for asymmetric encryption algorithms. Okay, so what the Chinese remainder theorem states that is, suppose there are numbers like M1, M2, and so on, MR. Some numbers are there. So these are pairwise relatively prime. These numbers are pairwise relatively prime. Means M1 is relatively prime to M2 and M2 is relatively prime to M3. So M3 is relatively prime to M4 and so on. So finally MR minus 1 is relatively prime to MR. So this, if this condition satisfies, okay, if this condition satisfies, means if these numbers, whatever the given set of numbers are there, if these are the relatively prime numbers, then there will be a there will be a number that is X. Okay, there will be an integer X, so which is congruently equivalent to A1 mod M1. Okay, A1 mod M1, and a number X is congruently, the same number X is congruently equivalent to A2 mod M2. And X is congruently equivalent to AR mod MR. Okay, AR mod MR. Then we need to find the X value. So that is, we'll have a unique solution. Modulus M is equals to, this capital M is equals to M1 into M2 into and so on MR. So we, which is given by, that is X, it will have the unique value, that is X. So X, what is X value is? X is the summation of AI, MI, YI, mod M. Okay. AI, MI, YI, mod M. So where this MI is nothing but this capital M by MI. What is capital M? Capital M is nothing but it is multiplication of all the given integers like M1, M2 and so on, MR. And MI is a particular integer. And YI, what is YI is? YI is the inverse of this MI. Okay, YI is the inverse of MI. So obviously MI will have the inverse because all are relatively prime, isn't it? M1, M2 and so on, MR are the relatively prime numbers. So it will have the inverse. So mod MI. Okay, so for X, for 1 is less than or is equals to, I is less than or is equals to R. So we are going to take a set of numbers, not sequential numbers. Okay, instead, whatever the numbers, we are going to choose all of the relatively prime numbers. Okay, we are going to choose all relatively prime numbers. If these, when we'll say that a number is a relatively prime, whenever the GCD of two numbers is 1, then it is a relatively prime number. Then, so X is congruently equivalent to A1 mod M1. So there will be a number X, and the same number X is congruently equivalent to A2 mod M2. A2 mod M2. Okay. So this is the theorem. So we need to, so what the Chinese remainder theorem is all about is, for a given A1 and M1 values. So we'll have a set of relatively prime numbers, and relative prime numbers are like these are the relatively prime numbers. M1 to MR are the relatively prime numbers, and we'll have a given set of A1 to AR. So for a given set of these two values, we have to find the X value. Okay, so in all these cases, X is the same. So by using this formula, we need to find out the X value. And that is when M1 to MR are the relatively prime numbers, and if the condition satisfies, that is X is congruently equivalent to A1 mod M1 and X is congruently equivalent to A2 mod M1 and so on, then X, there will be a unique solution, that is X. So a unique solution will be there, X. So X value can be calculated by using this formula. So where number will have the inverse. Okay. So if we consider the example, so example is so X is equals to 5 mod 7, and X not is equals to, X is congruently equivalent to 5 mod 7, X is congruently equivalent to 3 mod 11, and X is congruently equivalent to 10 mod 13. So this will have a unique solution, that is the X value. So whatever 894 mod 1001. So then this will be the whatever the mod value, that 894. What is X value? X value is the 894.
Can you show the formula once?
What, ma?
Can you show the formula once?
Yes, yes. We'll implement. Otherwise, we just yes. We'll go through the. So anyway, for this example, we have the X value. So we'll go with another example. Suppose there is a form. There are some numbers, relatively prime numbers, M1, M2, M3, like X is congruently equivalent to 1 mod 5. All of you note this and calculate. Note this example of Chinese remainder theorem. So X is congruently equivalent to 1 mod 5 and X is congruently equivalent to 1 mod 7. Okay, that is 1 mod 7. So 1 mod 7. And X is congruently equivalent to 3 mod 11. Okay, 3 mod 11, that is not 4. So all of you take this value, and so, and we need to calculate the X value. So directly, so in order to calculate the X value, so according to the formula, it should have, so what is that? Let me display the formula. So this is the formula. Okay, so first we should take this, we should calculate mi value, and we have to calculate the yi value. Okay, yi, that is inverse of mi. Okay, so we'll go with the step-by-step procedure. So X is congruently equivalent to 1 mod 5 and X is congruently equivalent to 1 mod 7 and X is congruently equivalent to 3 mod 11. So this is the thing. So step 1, so what we need to do is, in first step, first we have to calculate the capital M value. So here capital M is nothing but M1 into, so all of you note this, M1 into M2 into M3 and so on, MR. So where M1, M2, M3 are the relatively prime. So first of all, in this example, what is M1, small m1, and what is M2 and what is M3? Small m1 is simply 5. This is m1. Okay, 1 mod 5, in that m1 is the 5 and 1 mod 7. M2 is 7 and M3 is 11. Okay, so these are the given values. So here in this example, what is M? Capital M? Capital M is nothing but M1 into M2 into M3. That is 5 into 7 into 11. What is the value?
385. No?
Very good. So 385. Capital M is 385. And then we need to calculate. Okay, so we got this capital M value. So according to the formula, so if you see the formula, we need to calculate MI. We need to take the summation of all these MIs. Summation of this MI. What is MI? MI is nothing but capital M by small mi. Understood? So we have calculated capital M. Now we need to divide that with the small mi. Means suppose if I take I value as 1, so we need to calculate capital M1. What is capital M1? What is capital M1? Capital M by small m1. Okay, if I take I value 2, so we need to calculate M2, capital M2. So capital M2 is nothing but M by M2. So we have to calculate. There are 3 MIs, right? I mean M1, M2, M3. 3 relatively prime numbers are there. So we have to calculate M1, capital M1, capital M2 and capital M3. Okay. So first capital M is 385. And then, so all of you note down. So we'll continue. Next, now we need to calculate capital M1 and capital M2, capital M3. So what is capital M1? Is capital M by M1, capital M by M2, capital M by M3. What is M385? You know that, right? What is M1, small m1? Small m1 is what? Is 5.
5.
Yes, very good. So small m1 is 5. Small m2 is 7. And m3 is 11.
11.
Is it? Is 11. Okay. So this one. So can you calculate what is the result?
77, 55 and 35.
Very good. So 77, 55 and 35 is the result. So we have calculated capital M1, capital M2 and M3. So what is the formula? Formula is MI is nothing but capital M by small mi is the formula. So according to this formula, we have calculated this one. Next. So according to the formula, we have to calculate what? We have to calculate yi also. Okay. See this formula. So we have to calculate this one also. Yi. So what is yi? Yi is the inverse. Okay, yi is the inverse. So simply, so what we need to do is, so we have to take, we have to calculate the inverse of mi. So what is the inverse of mi? What is mi? Mi is nothing but m1, m2 and m3. So m1 is what? Okay, let's go with it. Yes, m1 is 77 and m2 is 55 and m3 is 35. 35. So 77 inverse. So inverse of 77 in mod capital M is 385. Okay. So inverse of 77 in mod 385 means we'll go with it.
Small m no, ma'am.
What small m?
Mod small m no, ma'am.
Mod small m.
That formula, ma'am.
Okay.
Yi is equals to.
Not small mod. Ah, yeah. Yes, you are right. Mi, mod mi. Okay, so we'll go with, we'll calculate yi. That is inverse of mod small mi. So here is nothing but, so how can we take? Simply we can take, so whatever, so what is mi? Suppose if I value is 1, m1 is 5, mod 5. So here we need to calculate the inverse. So here, what is capital mi? M1. Not capital mi. Mi. Mi means capital M1. Capital M1. What is capital M1?
77.
77. So 77 into, so inverse of 77 is equals to 1 mod 5. This is the, okay. So inverse of 77 is equals to 1 mod 5. How can we get this? Simply, so we have to take this. So first of all, 77. So this is in the form of AX is congruent, isn't it? Multiplicative inverse. A is congruently equivalent to 1 mod 5. Here A is nothing but 77, X is nothing but this one. Okay, inverse value. So we need to calculate this inverse value. How can we calculate this inverse value? So first of all, A and this mod 5 should be what is GCD of A and 5 should be 1. Okay, so that is GCD of 77 and 5 should be 1. Tell me, GCD of 77 and 5 is 1 or not?
Yes, ma'am.
Yes, very good. Why? Because 5 is a prime number. If 5 is a prime number, so the common factor with another number is obviously 1. So GCD of 77 and 5 is 1. So that we'll get what? It is 77 will have the inverse. That is, we can easily find the X value. Okay. So what is X value? Simply you have to substitute like what? 77 into 1, 77 into 2, 77 into 3, 77 into 4, up to 4, because mod value is 5. Here we'll get 77. What is 77 to 2? 154. You please tell the values.
231.
Okay. And what is 77 into 4?
308.
Okay. So 308. Mod 5. What will get? Mod 5. What will get?
2.
Where will get 1? 77 mod 5 will get 1? No, I guess. 154 mod 5 will not get 1. Will get 4. Okay, here 77 mod 5 will get 2. And 154 mod 5 will get 4. And 231 mod 5 will get 1. Isn't it? Will get 1. 308 mod 5 will not get. So this is the here. Okay. 231 mod 5 will get 1. So then what is the X value? This is the multiplicative inverse. Multiplicative inverse of M1. M1 is 77. Multiplicative inverse of 77 is what? 3 under mod 5. You understood? You understood or not?
Yes, ma'am.
So we got 3, isn't it? So what is this 3 in our formula? If we take, what is this 3? 3 is nothing but y1. Y1 is 3. So now we got capital M1. Okay, capital M1, M2, M3, and we know what is AI. AI means A1, A2, A3. So A1, A2, A3, all these in this example, all these values A1, A2 are A1 and A2 is 1. A1 is equals to 1, A2 is equals to 1, and A3 is 3. Okay, and we calculated M1, M2, M3 values. Now we have to calculate, we have calculated Y1 value. We have to calculate Y2 value. So once we get Y2 and Y3, we can directly substitute in this. Now, how can we calculate Y2 value? So same formula. Y2 is nothing but